Good afternoon. Thank you for joining and welcome to Codeware's What's New in Compress 2017 webinar. My name is Brian and I'll be one of the organizers for this webinar. Today, we're showing you the new features included in Compress Build 7700. Please feel free to ask questions throughout the presentation by typing them into the webinar control panel. We will do our best to answer as many questions as possible during the scheduled Q&A segment, and we'll post these online within the next few days. Now, I'd like to introduce to you our engineering manager and today's presenter, Matt Hyland.
Thank you, Brian, for that introduction, and welcome everybody to our What's New in 2017 for Compress Build 7700. We have got a great release for you guys this year. Our development team has been hard at work bringing you all these great new features. And I'm excited to report we have over 600 people registered for this webinar as well. So I know we'll have a Q&A session at the end, and I will try to get through as many questions as I can. But if not, I'll be posting them online afterwards as well. And if you guys missed it, a few days ago I had actually done a What's New in our Inspect release as well. So if you guys are curious what other product offerings we have, feel free to check that out. That's now been posted online. But what are we going to be talking about? What are some of the new features in Compress 7700? Well, today's topics that I want to go over are going to be the project panels. We've added in new project panes, I guess, for you to help organize some of your work. So with that, we have a specification sheet data pane, we've got a component tree pane, and I'm going to show this to you in the software as well. It allows us to double click on components if we want to edit them, things like that. Now we've also revamped the Nozzle dialog. So we've just restructured a little bit of how the workflow goes for modeling our nozzles. Now with that, we've also introduced a new nozzle type. So we can now model intermediate nozzles. So that's going to be out of the codebook figure UW 16.1 Sketch K. Okay. Now we have advanced FEA options available for you. So if you guys are familiar with Compress, you know we already have built-in finite element analysis available. We've really just opened up these options to give you guys more control over your runs. And with that, we also gained the ability to do FEA on some other things like clips and platform support. So I'll go through a little example with that for you as well. Now, for our neighbors to the north of us, the MBC 2015 has been updated in Compress, so both your wind and seismic calculations can now be run to the 2015 edition. Now, we've added in Appendix 9, the jacketed vessels for 7700 as well. So this has been updated both for Division 1 and Division 2. And I'm going to go through an example of how we model the two types that we've added in Compress for you. And finally, I'm going to touch on the heat exchanger updates. So we've integrated the tube layout program into our wizard. So with that, we're now able to model tie rods and spacer tubes and pingent rods and plates, things like that. And I'm going to show you how that translates into a solid model, which can then be used for drafting and things like that. So let's get on with the first feature, which is our project panel. So I just mentioned to you, we have a specification sheet data, and we have a component tree. So you can see on the left, it's your specification sheet. And this is going to have things like your general information, code requirements, design requirements, and obviously the component tree here on the right is the components for the vessel. So let's open up Compress. And here's my sample file. I have a tall tower. And this is really where having the component tree is going to show you the power of using this feature. So with the component tree, everything is listed out here on the right. So you can see if you select cylinder 6, it'll highlight the component that you're looking at and give you some properties down below. Now, if you double click on it, it'll actually open up the dialog itself, and then you can go in and you can make edits to this as well. So this is great if we're going to make edits to this one component and then move on. But if we want to make edits to, say, the entire vessel, you know, we're in a meeting, we have to say, you know, what happens if we were to increase the pressure or the temperature by a certain amount? What would happen? Well, that's where having this specification sheet data pane on the left is really handy. So again, we've got our general information, your code requirements, and your design requirements. So for example, if you wanted to change it to 450 psi, you could do that, and it's updating the model right now. So when you right-click to edit a component, if you choose to do it that way, you can see that the pressure has now been updated for this. So it's a little bit easier way of navigating through the software. Now, these are what we call dockable panes, and what does that mean? It means we can move it around the software. So, for example, with the component tree, if you click on the heading and you drag it, You can see here there's arrows. This allows us to dock it on the top, the left, the bottom, the right, wherever you guys would like to. You can even leave it floating. I personally like to keep it over here on the right. And something else you can do, you can also pin it and unpin it. So I just click the unpin option, so this will auto-hide it, and it's sitting right there on the right. So you can pin it. Now if you happen to close it and it goes away, how do we get it back? Very easy. You just simply right-click on the top here and you select the componentry option. And the componentry will pop back up for us. Okay, so those are going to be the new panes that are going to be available to you. Now I showed this off to a couple of clients while we were in the Q&A process, and we got a lot of great feedback on it. So they found it to be very useful. So I hope you guys do as well. Okay, so those are going to be your project panels. Now let's talk about the Revamped Nozzle Dialog. So the Nozzle Dialog has been restructured, and probably the biggest change that we made is we've replaced the nozzle types with nozzle styles. So I've got an image here from the older versions, from 7600 and prior to that, and the new 7700 build. So if you guys remember, we used to have 12 different types of nozzles with various weld configurations. So types 1 to 4 would be pipe, type 1 is a straight set-in nozzle, a type 2 is the same, it has a repad, and 3 and 4 have internal projection, a type 5 is set-on coupling, 9 and 10 were heavy barrel forgings, and 11 and 12 were stud pads. Well, instead of remembering that, we just simply rename them to really what they are. So now you have a style right here. So you're going to have a uniform thickness. This would cover your types 1 to 4. You have variable thickness. That would cover types 9 and 10. Studding outlet, that's going to be 11 and 12. And then we have things like long weld necks, elliptical manways, and couplings that we can model as well. Now the big thing that we've added in here is now with the attachment style. So we have the set in and the set on. Again, those are types 5 to 8 would be set on, but there's the new intermediate selection as well. So again, this is going to come out of figure UW 16.1 sketch K, and I'll show you an example of that momentarily. So let's go through the new nozzle dialog. So what I'm going to do is I'm going to open up a new file. I'm just going to click on my Division 1 document, and what I'm going to do is I'm going to just model a very quick vessel. Let's say we just need to take a look at the top of a vessel. So I'll put a Hemi head in here. I'll just make this 1, and I'll model my cylinder. Now I'm just accepting the defaults. This is just what we call freeform modeling, like so. So let's go ahead and model a nozzle. We'll put a nozzle on the cylinder, and then 1 on the head. So if I come up to the action menu, or the nozzle menu, I'm sorry, we'll select Detail Design. So this is the new nozzle dialog. So we haven't made any drastic changes. We really just restructured where things were. So now when you open it up, we're going to ask you for the drawing mark and the identifier, okay? And along those lines, we'll also have an option for the service. So if you're taking this file out to, let's say, a plant layout program or to a drafting program like SolidWorks or Inventor, you can take out these services as properties. So we'll select this as a process nozzle, and we can move on. Now for the style, we'll just do a simple pipe, which is probably the most common. So I'll select a uniform thickness, and we'll select set in. Okay, and from there we'll go through and we can specify our material. If there's any material options specified like post-weld heat treating, normalization, things like that. And then the dimensions of it. Now the diameter and the thickness, you guys know, we can always type it in. So if you do have those odd shapes that you need to maybe roll in the shop, you can simply type it in. Or what I like to do, I go to my standard size lookup right here, and we look up our pipe library. So we can look up pipes, threaded couplings, and studding outlets. So let's make this a 16-inch, and we'll select standard schedule, click OK, and we'll move this over. So we've got the dimensions. Great. So from here, moving down, we're going to locate the nozzle. So this really hasn't changed. This is in the same place as it was. But the difference is we've moved the orientation down here. So you can specify this as tilted or an offset nozzle. So if you've got a hillside nozzle, we can model it. Now I'm going to make it radial. And what I'll do is I'll attach it to the top head here, like so. And I'll just fill out some information right now. And we'll just put it 5 inches away from the center line. All right, so we're going to click Next. And we're going to come to the second screen. So again, this still looks very familiar to what we had before. Now, the difference here is, when we're reviewing our areas, we come down and say, okay, I've got, just under 15 square inches, and I require, just over 1. So this is meeting code requirements, so great. We don't really need to do anything here. But if we do run into the situation where, we may have to add a reinforcing pad, we've added that option onto this dialog just so it's easy to see, if I were to add a reinforcing pad, how much effect would that have on my area? So now you just simply check the option, has a reinforcing pad, and the pad dimensions in the image will show up for you. Okay. Same thing with internal projection. If you specify internal projection, you can just set it here, and then again you can review the areas because that will affect it. Alright, so what are some of the other things that we've restructured? Well, if you guys remember, the flanges used to be specified on the first page. You could specify your B16.5 flange or your custom Appendix 2 flange. Now, in 7510, we added in elbows as well, so those used to be specified on this page. Really, those are nozzle connections, so we just put them all under our nozzle connection dialog. So if we come down to the bottom left and click on the nozzle connection button, we can specify standard flange, a custom flange, or an elbow connection. So if I wanted to put this on an elbow, I can click Add Elbow Connection, click OK, and I can work my way through the elbow dialog. So I'll just put one on here quickly. Again, I'm going to accept a lot of the defaults just for demonstration. I'll click OK here, click OK, and then the elbow's been specified. And as always, you can always specify your WRC 107 or your WRC 537 as well. If you want to perform FEA, we can go into the FEA details and set that up, and I'm going to be coming back to that shortly. So I'll click OK, and there's your nozzle with an elbow specified on it. Okay. Now let's have a look at that new intermediate nozzle type. So again, I'm going to come back up to my nozzle menu, and I'm going to select Detail Design. So what I'll do is I'll take a uniform thickness, but now I'm going to select intermediate from the attachment style. Okay, and I'll just use the standard sizes here, and I'll just locate this on the cylinder about halfway up, and we'll make it radial again. So I'm going to go to the second screen, and there are a few things to be aware of if we are going to be using this attachment style. So if you guys are familiar with UW16, there are various sketches in there. But the big thing when we're dealing with these intermediate nozzle types is there is now a gap that we have to consider. Right, so from a fabrication standpoint, we always have a gap, but from a calculation standpoint, look closely between what we would consider a uniform set-in nozzle versus this intermediate nozzle. So there's now a new input for radial clearance, because if we look at that sketch, the value of D actually goes to the inside of the nozzle opening versus going to the OD of the nozzle. Okay, so you can actually specify a larger gap here, and this is going to play into our area calculation. So be mindful of this when you are modeling this. Other than that, everything else is still the same. So you can just simply model it. You can put a reinforcing pad on it, add nozzle connections, things like that. So I'll click OK, and there's your new intermediate nozzle. Okay. So that's how we've revamped the nozzle dialog. So we just simply restructured it, and we just renamed the nozzle types to the nozzle styles. Nothing else has really changed. It's a little bit easier order to go about modeling your nozzle. Okay, so along those lines, let's have a look at the new detailed FEA, because as you guys, I mentioned before, we've always had FEA available for our nozzles, except now we've updated it to include more control and more configurations. So let's take a case, let's model a new file vessel quickly, and again, I'll take my Hemi head, and I'll put a cylinder on it like I did before. And what I'm going to do is just model a nozzle up here as well, because this is how it's going to be accessed. So I'm going to put a nozzle. I'm going to select Detail Design here. And again, I'm going to put on that top head. Like so. Now, to access the FEA, we're going to click on the FEA Details button here on the second screen of the nozzle dialog. Okay. And this is familiar to a lot of you. This is how we would come in. We would bring our loadings over for the various conditions, whether it's weight, operating, thermal, things like that. But the difference here with 7700 is there's now a button for Run Detailed FEA Analysis. So if you want to take that FEA analysis one step further, you want to get into the nitty-gritty of it, you can click on this option, and this will actually launch the Nozzle Pro interface, because as many of you guys know, our FEA nozzles is a subset of the program Nozzle Pro. It's a wonderful program, the very accurate results. So now you're actually going to get full control over it. So this is the Nozzle Pro interface, and from here you can come in, you can specify loadings if you'd like. One big thing is the options. So some of these options we already have for you, but you can open up the ASME rules options, and you guys can get right into it, have more control over your FEA run as well. So if you guys do use it, come in here, get familiar with what you guys have available to you, because this is now available in 7700. So click OK, click OK. But one of the big things that we can do now is not only can we analyze nozzles, we can analyze structures. So many of you run into the situation where you have a column or tower and you have a platform on the top of it. And that platform needs to be supported by platform supports that might be welded onto the head. Well, within the new Nozzle Pro version in Compress, we can select to analyze a structure right here. Okay, and then down in the bottom right, you'll see the various structures that we can analyze. So probably a type 1 or 2 is what we'll want to use, so we can just select it from the pull-down list right here. Okay? And then we need to change some of the geometry, so the vertical plate thickness, we'll make that 1 inch. And I'll just put some default values in here. So let's say this was my platform support clip, if you will. So I can set it up, and then I'm going to click Run FE. I just changed input, so let me just change that quickly. Okay, so I'll run it. I just had a bad input there. That's all Nozzle Pro was doing, was just warning me. So it's running through the analysis right now, and this can take anywhere from 10 seconds to 30, sometimes a minute, depending on the complexity, depending on what options you choose. Like if you make a very fine mesh, it might take a bit longer to run, but you can see it right here with the progress bar that it is actually going through the post-processor, as well as on the left now you see we're also running through the different load cases as well. So you can see that it's cranking through the calculations right now. And then when it's done, we're going to have the results right here in front of us. So it's done, didn't take too long, and I'll just open up this window right here for us, and we can review the results. So if you guys aren't familiar with this program, if you want to review tabular results, they're here on the left, and graphical results are on the right. So again, we can come in and see are there any ASME overstressed areas. They're not, so this would be fine. And then you can go down to the different load cases and you can review the stress plots. You can even have a look at the deformed vessel itself, and you can investigate to make sure, if we put loadings in a certain area, are they translating over how we would expect it, things like that. So again, we've inherited some more functionality with the new FEA details for you as well. So I'm going to close out of this, click OK, and we can continue on. So again, if you need to access it, you just simply go through the nozzle and go to the FEA details dialog and click on the Run Detailed Analysis, and this will launch the Nozzle Pro interface for you. So again, you'll have more control over everything. All right, let's talk about jackets. I know this has been a wish list item for a lot of you for a long time. We're happy to finally get into the software for you. So we've implemented both types 1 and 2, and they've been updated for Division 1 and Division 2. So if you guys are familiar, type 1, it encompasses a cylinder, and a type 2 is it encompasses a bottom head and part of a cylinder. So in addition to adding the jackets, we also consider the closure members as well. So in Division 1, this is going to fall under figure 9.5. It's going to be figures F1, F2, F3, G1, G2, and G3. And then Division 2, it's going to include details. So it'll include detail 5A, B, C, 6A, B, and C. And I'm going to show you this momentarily. This will clarify some of this. As well as nozzle penetrations are also available for the jacket. But let's actually go into Compress and let's model one quickly. Now I'm going to use a new tool called the Vessel Wizard. Actually, it's been in for a while, but I'm going to use it in conjunction with the new jacket feature. So under the File menu, I'm going to select Vessel Wizard. If you guys aren't familiar with this, this is a great tool to get a very quick vessel. Essentially what it is we take the specifications from a customer, we fill it out, and we can model a vessel very, very quickly. So I'll put this on a skirt. I'll just accept the defaults, click Finish, and there's my vessel. Okay, so with the jackets, they're added under the component menu. So you come up to the component menu, come down to the bottom, we're going to select jacket right here. So this is the jacket dialog, and both types 1 and 2 are going to share the same dialog. So if you want to do a type 1, again, it encompasses the cylinder, and type 2 will encompass the bottom head. So we'll take a type 1, and then we'll fill out the jacket design conditions, so the internal, external pressure, corrosion, temperatures, things like that. And then we also have parameters for the jacket shell. So we try to build some intelligence in, so we know it's a 60-inch vessel, so we're going to recommend something close to it. So in this case, it's going to be 64 3/4 of an inch. Okay? We can change this if we need to. We'll then determine what the shell thickness needs to be for the jacket, things like that. So for the length of the jacket shell, how long is the jacket? So we'll make it 60 inches. And you guys can also specify multiple shell courses for this as well. Just simply, you can type it in, or you can use the arrows here and increase it. And when you do that, you can specify different lengths for those jackets. But we'll just keep it at 1. And then the other input we'll need here is the location of top closure bar centerline from datum. Now what this input is our datum is our XY plane right here. How far up the vessel are we going to start it? So let's do 120 inches. Okay? I'm going to click Next, and this will take me to my jacket closure dialog. So I was telling you guys before, we have the closure of the shell. These are figures F1, F2, F3, and the closure of the jacket are going to be G1, G2, G3, things like that. So that'll clarify a little bit of what I was saying before. It's really just the weld configurations that we're going to use. Again, I'm just going to accept the defaults here and click OK. I'm going to click OK, and there is the jacket. All right, so that's how we're going to model a Type 1 jacket. Again, you can edit it by coming over to the component tree, double-clicking on it, or you can right-click on it and select the jacket, and it'll open the dialog back up. Okay? But how do we do a Type 2 jacket? Well, again, let me make another model quickly, and I'll use the freeform feature that you guys saw before. So I'll just accept the defaults here. Like so. I'll put another 2-to-1 head on the bottom. Okay, so there's a very, very quick vessel that I modeled. Now, if you don't want to go to the component menu, I know some of you, like myself, I like to use the shortcuts on the side here. Now, the jacket has been added to this. It's right here, just a little bit down from the middle. So we'll select jacket, and the jacket dialog will come up. So from here, I'm going to select a Type 2, and nothing else has really changed. We're going to fill out our jacket design conditions, the jacket shell information. So what I'll do is I'll put this at, say, 65. And then we've got information for the jacket head, because again, this is going to enclose the bottom portion of the cylinder, the vessel. When you click Next, this is going to take us to our jacket closure page. And again, we can fill out different closure styles that we want to use, things like that. I'll just take the defaults again, click OK, and that's now been modeled. So there's your Type 2 jacket. Now, a couple other things to mention since we're on the topic of jackets. So in Division 1, this is going to fall under Appendix 9. In Division 2, it's in Part 4.11. We can also put nozzle penetrations through the jacket as well, so we can model it on a cylinder, and we'll go through the jacket. We can also put supports on these, so we can do lugs, legs, skirts. They can be attached to the jackets as well. And then finally, a big one is liquid levels. A lot of people have been using the program for a while know that we automatically account for that static head resulting from the liquid level. Well, with the jackets, we can actually specify 2 separate liquid levels as well. So if you do have that, we can model it in compress. So just to give you guys an FYI. Okay. So let's talk about the heat exchangers. I know many of you watching are heat exchanger manufacturers, so let's go through some of the changes that we've done this year for you. So I mentioned before, the tube layout program has been integrated into the heat exchanger wizard. Okay, so with that, we're able to now do a full tube layout. We can model things like tie rods, spacer tubes, impingement devices, things like that. So we've enhanced the capability a little bit. So let's actually go through a model that I've got here. So I'm going to open Compress back up. I'm going to go to my heat exchanger example right here. And I'm just going to right-click on the heat exchanger, and I'm going to edit the tube sheet. So the heat exchanger wizard is still the same. We haven't changed anything here, but what we're going to do is when you're going through modeling the heat exchanger, obviously we're going to ask you for the calculation methods. You know, is it going to be a TEMA design, ASME, or do we want to run it to both? And then we'll fill out our design conditions up here. Now the difference here is when we get to the tubes and shell page, down the bottom left, there's going to be an option for include an optional tube layout. Now this is going to be required for our solid model because many of you are actually exporting these models out to SolidWorks. Now if you're an estimator, you know, you're not really concerned about the layout, you just want to get a rough idea on, you know, weights, thicknesses, things like that, you can actually turn this off. So in order to satisfy a UHX or a TEMA calc, we really just need things like your tube pitch, number of passes, and the tube pattern itself. Okay? But we do want to take it one step further. We are going to include an optional tube layout, and then you can select the pass partition layout from this drop-down list as well. Now, if any of you are using the HTRI program out there, you know we have a bidirectional interface, so you can actually bring those tube layouts directly in from HTRI and save yourself a bit of time. Okay, so we've checked the option to include optional tube layout. So when that happens, the tube layout page right here is going to appear. So I'll click on it, and this is our tube layout. So we can do things now. We can mirror inputs. So if you wanted to lay out some tubes, you can mirror them vertically, horizontally, or just work in a quadrant. And we can do things like, you know, obviously we can restore tubes. We can add tie rods. You can add long dummy tubes, short dummy tubes. You can plug the tubes. You can add seal rods, seal strips, even skid bars. And I mentioned before we do have impingement devices. So if you click on this, we'll ask you would you like to add an impingement plate or add impingement rods. Pretty basic inputs here. So if I wanted to add impingement rods, I would simply just fill out the dialog. So things like the rod diameter, you know, how high above the tubes are the rods, and then the number of rows. And we're going to place them based on rod layout patterns. So, you know, typically it's going to be a 30-degree triangular pattern. And then we'll need to know the rod pitch. And then we'll model those for you. But the big one I want to show you guys are the tie rods. Now I've modeled some of them here. Now if you need to add a tie rod, just click on it, and if you click in place of a tube, we'll add the tie rod. So you can see here I'm adding them. Now when we do add the tie rods, the associated spacer tube is modeled with it, and we're pulling these standards right from TEMA. So we're making sure that the proper geometry is being passed into the solid model for you that way. And then on the left here, we've got some basic calculations that we're doing for you. So if you have a thermal designer working in compress, they can have a look at this as well. Okay? So I would click OK here. And then as you guys know, I've done this in previous webinars. If we wanted to export this model, you could simply click on the 3D export button, and we would take this solid model outside of compress. Now I'm going to show you something in SolidWorks because I think this is a really great feature. So I've actually gone ahead and exported it through our Codeware interface to SolidWorks. So we bring it in as an assembly, and as you can see, all the parts from compress have been renamed in our SolidWorks assembly. Now we have this handy tool, which is, this is all available right now, but if we go to what we call the configuration manager, I'm going to double click on the bundle components, like so. So what this is just essentially a way of telling SolidWorks, I only want to see the tube sheets, the baffles, the tie rod space tubes, and maybe the tubes. Now I've suppressed the tubes in this model. But notice how those spacer tubes and tie rods have now come over. Now this is key because these are now being translated over to a drawing, and we've actually done some drawing automation for you guys this year. So if you guys haven't had a chance to download the new Codeware interface 7700, I encourage you to. Okay? So I've actually got the drawing open as well, so I'm just going to switch to it. And this would be the drawing. So we've automated things in here like your general arrangement drawing, like you see here, so we can place the 3D view, the front left view, and we bring over the design data. We've also done things like automate your tube sheet details, like so. So I've got your tube sheet, diameters, pitches, things like that. We've got nozzle details detailing it. I'm going to come back to this in a little while. But one thing I want to show you is I set up a bundle details page here. And this is actually the view you were looking at. So this is my bundle. So I've got my tube sheet, my baffles, tie rods, things like that. And I've got some representations of what the tie rod would look like. We can dimension those. But the big thing here is because I know all the lengths of those tie rod or the spacer tubes, I can pull those over. So you guys can very easily, within almost a few seconds, generate a cut list for your spacer tubes. Okay, so that's key. Now again, I'm actually going to be doing another webinar in a few more weeks on the Codeware interface. So I encourage you guys to show up, and I'll go through and like how do we set these tables up, you know, how does this work, things like that. But I just wanted to show you that when we specify them in Compress, we can very easily move this information over to other programs as well. Okay. So that's been a big update with the heat exchanger wizard, is, you know, the integration with the tube layout. So if you guys want to start with a tube layout before you do anything else, you can, or you can add it in afterwards as well. It's up to you. Okay. All right, so let's talk about what's coming. Now, in typical webinars, I always like to show people what we're working on to give you guys a sneak peek. Well, our sneak peek is we have been working on an ASME Section 9 weld form and project management software. We're calling it Shop Floor. And I'm just loading it right now. It's on my other screen. I'm just going to pull it over right here. So this is our Shop Floor program. So this program is intended to manage all of your welding forms, your WPSs, PQRs, manage your welders, and even your jobs. And because it's a cloud-based program, we can easily deploy it, you know, across many organizations. So a lot of you guys watching, you've got multiple shops across the US or across Canada. Well, we can actually manage all of those places. So many of you know every shop has its, you know, limitations or what we can do. So, you know, a work site or a job or a shop may only have cranes capable of a certain weight, whereas another one might be able to go higher. So you can manage where your jobs are going. Now when you log in here, you're going to have panes, so you can get right to it, but we also have a message center right here. So for example, if you're in jurisdictions where, you know, PQRs expire after a certain time, or you have welders that are going to be expiring, we can search those databases for you and we can easily present them to you to say, welder X is coming up for expiration, and then you can take the appropriate steps to get him requalified. Okay. Now on the left here, we've got our menus. So we've got, you know, your company standards. You can set up settings and defaults. You can set up employees. So if I click Find Employee, I can come in here. I can set up welders, foremen or supervisors, general employees, things like that. And you can edit their profiles as well. Same thing for the shop locations. So I've got a couple set up here. And these are just defaults. So I've got 3 shop locations. You can put notes in there to say, you know, they can handle this, things like that. Now notice as I'm opening these up, you have different tabs within Shop Floor. So you guys are all familiar with working with browsers like Chrome and Firefox. It's really the same style. So you guys can actually keep multiple jobs open at the same time and simply click through them. Okay. Now we can also keep track of your jobs, and I'll run through an example of this momentarily. Same thing with equipment. You know, we can set up new equipment for you and run through that. Same thing with welders. You want to create new welders, bring them in. We can set up the welding profiles as well. Now with the forms, what we've done, let's just open one up here. We've added in the ASME forms, so we've got section 1, 4, 8, and 9. And we've also added in PCC-1, because one of the things that's been coming up a lot these days is bolting and bolted joints, and you know, we have to track those bolted, the bolters. So we're able to do that within our shop floor program. And we also have the MBIC repair forms. So let me open up a section 9 form. You know, we've got our PQR, WPS, WPQ. We even have a preliminary WPS. But let's take a PQR. So click on this, and this is going to open up a blank PQR form. So you guys can continue. You can go through here and you can fill it out. You can actually pull customer information in here because we have the ability to set up multiple customers as well. So if you want to do a preliminary U form for Section 8, you could actually set it up and pull all of their information in ahead of time before it even gets to the final QC. Okay, so this option is available. You can fill it out. Now, one of the big features with Shop Floor is we've actually integrated it with Compress. So I can actually take that exported heat exchanger that you just saw in SolidWorks. I can export it from Compress, and I can load it into Shop Floor, and we can identify all the welds on the vessel, and we can look up the applicable WPSs and the welders that we have available to us. So let me show you how that's going to work. I'm just going to close out of this. So if we logged in, the phone rings, all right, we got a job, all right. So we've run it through Compress to get basic, numbers for thicknesses. Now let's see, what we have to do for welding. So under the jobs menu here, we're going to click Create New Job. And there'll be some basic information we'll need to know. First off, who is the customer? So we can look it up. Now you can always create new customers from here, but if you're a shop that has a lot of repeat customers, you can just simply select them from the list here. So I'll select them, and then we'll put the job number like so. And then the rest of the information we can always fill out at a later time, or you can fill it out now. But I'm going to click Create. Okay, so the job's been created. So now what do we do? So down at the bottom here, what we're going to do is click on the equipment icon, and we're going to click Create New Equipment because we can handle various types. So up here under the type of equipment, we're going to select an ASME vessel / heat exchanger. Okay? And the identifier we'll call heat exchanger 1. And then again, we can set up work sites, descriptions, things like that. But the power of this program is right here. I'm going to import that compressed design file that you just saw. So I'm going to click on the heat exchanger file because I'd already exported it, and click Open. And I'm going to click the Create button. Now when I do that, we're going to import this model into shop floor. We're going to identify every weld on that vessel. So many of you have seen that long seams wizard that we've had for a very long time, so we can position our longitudinal seams on our shells and our hemi heads. We're identifying all of those for you, and we're going to present them to you right below. So once this comes in, depending, a heat exchanger has a lot of welded joints, so it might take, 20 seconds or so. All right, it's done. So now that it's come in, we can click on the weld editor right here. Okay. And we've broken it out, so you've got your categories A, B, C, and D. So we know from the code book, category A's are longitudinal seam, and then there's B, C. You've got flanges, nozzles, like nozzles would be category D. But the big thing is we've already gone through your database too. So you can see here we have a welds legend. So the blue represents that we've got a WPS or a welder assigned to it, so maybe we've already been in here and we've saved it and we're coming back. The gray means that we have a WPS available, we just haven't assigned it yet. And then the red means there's no WPS, and then we can go through the procedure of possibly getting a WPS qualified, things like that. Now the big thing here is, especially when something is in design, you can easily bring this in the shop floor and see what WPSs do I have available, because we can design any of these joints the way we would like it, but at the end of the day, if we don't have WPSs, it's expensive, it's time consuming to get new ones brought in. So we can use what we have. So let's just open up this category A joint, and we'll click on the cylinder. So we've identified the longitudinal seams on the cylinders. So under the WPS column, I'm going to click the search icon, and here are the applicable WPSs that I could use for this job. So I'm going to click the first one here. The WPS has now been assigned to that weld. Now based on that, we're going to filter the welders. I can search for a welder, and it's just retrieving them for me. I've got 2 welders that can do this job, and they're at the shop locations that I need, mind you. Okay? So I can select this employee, and then now I've assigned the WPS and the welder to this. Again, if you didn't have a WPS available, you could generate a PQR, and you can go through those steps. And notice that now our icon has turned to blue, so we've got it assigned. Okay, great. So let's say we've gone through the whole vessel and we've assigned all of our welds and our welders to this job. I'm going to scroll up to the top and click Save. Now, when we save this vessel, what we're doing is we're appending all of the welding information, so your WPS numbers, your welder, process information, to that XML 3D file. Okay. Now, the real big power, another big point here, is I can now export this file. So if I want to take this over to drafting, what I could do is under the menu right here, click the Export to Drafter 3D. And Drafter 3D is what we're calling the drawing functionality within our Codeware interface. So I could click on Drafter 3D, and I'll export the XML 3D file, and I will touch on that momentarily. The other option you have in here is export your document package. What this will do is collect up all the WPSs from this job and put it into a zip file for you, so if you need to send this to a client or somebody wants to review it, you can easily send this to them. Okay? But let's say I want to send this to drafting. I'm going to click the Export to Drafter 3D button, and now it's saved that file. And again, I'm going to go back to my SolidWorks model here, where I've already brought in the model. Now I told you guys before we've automated the drawing. So with the nozzles, I've automated the detailed drawings here. But notice something. I have the WPS numbers now automatically populated on this drawing. So I've gone from compress to shop floor to SolidWorks within a very short period of time, gotten my detailed drawings and then my WPS numbers, because I know some jurisdictions out there are beginning to require this. Now, if you have your own company standards and we don't like to put them on the details like that, that's fine. We can always turn it off. But these are appended as properties now, so you guys can set up your own tables and you can fill out information. And again, I'll be doing another webinar specifically on the Codeware interface on how we can set up your tables, populate your WPS numbers, your welders, things like that. Okay? But I wanted to show you what we have available to us today. And there's a few other things that we can do in shop floor here. We can even run welder reports, so we can get welder continuity. You can do qualification summaries, requalifications required, things like that. So we can run various reporting for you as well as you can keep track of all of this. So this is going to be a nice paperless solution for you moving forward. And if you guys are curious about this product, feel free to contact us. Contact sales@codeware.com, or if you're an existing client, get in touch with your account manager. We'd love to tell you more about this, and we could set up demonstrations and show you how we can really benefit your organization by using our shop floor program as well. So that's what's coming, guys. So we're planning on having this released in Q1 this year. So we're working hard on the final QA to get this out the door for you. So again, if you guys are interested in it, please give us a call today or email us, and we'd be happy to tell you a little bit more about the product. Now I just kind of want to touch on everything that you just saw, and this falls under what a lot of people call integration. So what did I just do? I went from compress to shop floor to the Codeware interface. Now for the heat exchanger folks out there, we have a bidirectional interface to compress. So you could go from HDRI to compress to shop floor to your drawings, or you can go from compress to the Codeware interface. It's up to you. But the point here is that you can easily move your data, this is your data, around different departments. So I could design the vessel and compress. I could then check to see what WPSs I have available in shop floor, append that information to the file, load it into the Codeware interface, get my detailed drawings, and then populate tables or whatever I need to, maybe for a weld map, on my drawings as well. So this is the integration that we've been talking about for years that's now available to you as well. So again, any questions at all, guys, I encourage you to contact us, and we'll be happy to go over any of this with you. So let's wrap up what we talked about today. So to summarize everything in 7700, we've introduced project panels that now display vessel-specific information and provide easy access to component dialogues via the component tree. So again, if you double-click on a component, it'll open right up for you. We've revamped the Nozzle dialog to make the workflow a little bit easier for modeling them, and we've also included the new intermediate nozzle type per UW 16.1 Sketch K. We've added more FEA capability for you guys, so you can do things like clips on heads, you get full control over the parameters for the FEA analysis, things like that, and that's going to be accessed through the Nozzle dialog, going into the FEA details and clicking on that Run Detailed Analysis button. We've updated the heat exchanger wizard to include further integration of the tube layout program, so we can now consider things like tie rods, spacer tubes, impingement devices, and then we can take those into the solid model, which, as I just showed you, can then be translated into SolidWorks or Inventor. We support both, so it's up to you. And finally, we can also analyze jacketed vessels for you per Division 1 and Division 2. So again, these are going to be Appendix 9 in Division 1 or Part 4.11 in Division 2. Okay. So at this point, Brian, I think it's time for a Q&A session. So I'm going to hand it back over to you and see what questions came in during the webinar.
Okay, thanks, Matt. Yeah, we do have a number of questions that came in. The first one, I see that the inner-outer corrosion is grayed out in the nozzle dialog. How do I specify corrosion allowances for nozzles?
The inner corrosion is grayed out. Let's have a look here. Let's open up this one. So that's open. Oh, I think I know what they mean. Okay, so let's take this nozzle right here. So I'm going to right-click on the nozzle and edit it. I think what they're referring to is this corrosion right here if it's grayed out. And one thing I happened to forget to mention to you guys, Part of the new nozzle revamp, we've also added in outer corrosion for you, so you can specify outer corrosion for your nozzle now in Compress. Now, if you're in the nozzle dialog and you see this grayed out, what this means is it's actually a default setting in the program. Typically with nozzles, they're going to inherit the corrosion of the parent component. So if you specify 1/16 of an inch on the cylinder, that would get translated into the nozzle. It's just to save us input time, things like that. So to unlock that, simply come up to the action menu and select the set mode options right here, or you can press F7 on your keyboard. And it is in here. It's under the defaults. It's on the nozzles page right here. And if you go directly across, you can uncheck the option for nozzle corrosion allowance, same as parent. Okay? Click OK. And then when you come back in and edit the nozzle, those two inputs are going to be unlocked for you. So you can specify the corrosion that way. So it's a good question. So.
All right. The next question that came in, can I perform FEA for a nozzle that penetrates both the shell and jacket?
That's a very good question. Unfortunately, at this time, we didn't open up the FEA capabilities to handle the FEA for the jacket, the nozzle passing through the two of them. Now, one thing I forgot to mention to you guys is we do consider, I guess I didn't show you, but we do consider the jacket penetration. So if I open up my jacket example right here, I'm going to open up this nozzle. So if you do need to model a nozzle through the jacket, model it like any other nozzle, place it on the cylinder, and then what will happen is when you open up the nozzle and you go to the second screen here, there'll be an option for jacket penetration. Okay? And you can click on this and you can model the applicable figure from, in this case, Appendix 9 because it's Division 1, or the applicable detail from Division 2. So you guys can also do the jacket penetration now.
Okay, and along the same lines of the nozzles, do we have to have the Nozzle Pro software to run FEA?
No, that question does come up. The FEA capabilities, everything that I showed you today is actually included with your license. So you do not need to purchase a separate license of Nozzle Pro. It is included with your license of Compress.
Okay, and the next question that we have, do you plan to add more types of closures to the jackets?
Yes. So with the release, we released the closure members that we thought would be the most used in the industry. But we do have plans on adding to it. As in typical Codeware fashion, we always like to build upon features that we release. Now, if you guys have ones that you're seeing that are not there, feel free to write us and let us know. We can try to get those out sooner for you as well. But yes, there are plans always to add more features like that. So we will be adding more closures for the jackets.
Okay, now we have a string of questions related to shop floor. Do I need Compress to use shop floor?
No. How we broke this up is they are actually separate programs. Now, the big benefit of using the two is that we can load those files into shop floor for you and again identify those welds. But if you are in shop floor, you want to use it, you certainly can. This is a standalone program, so yeah, you can use shop floor by itself. But again, I always encourage you to use it with Compress, but it is up to you.
Will shop floor be able to import CEI's ProWrite welding procedures or paper forms?
That's a good question. I'm glad that question came up. What we're going to be doing, if you have paper forms or even database forms such as, like you said, CEI's ProWrite, we will be offering a setup service here where we can help you get your forms set up and get you guys up and running with shop floor. Now, if it's something that you guys are interested in, like I said, contact either your account manager or write into support, and we can be in contact with you and we can talk to you and discuss ways of how we can get it set up. But part of the shop floor program is there's also going to be a setup service if you choose to use it, and we can give you a hand with that as well.
Will shop floor indicate which welding variables are required?
Indicate which welding variables are required. Yes. How we set this up, it's very similar to Compress. So shop floor will guide you in populating all the essential, non-essential, and supplementary essential variables. So like Compress, as you guys know, when you run the report, we get a deficiencies and warning report. It's going to be the same thing here. So as you're filling out a PQR or WPS, maybe you don't have the proper number of bend tests or tensile tests that are required per Section 9. Well, at the top of the form, we're actually going to report that for you, and then you can say, oh, okay, I'm missing this, so I can go to that part of the form and fill it out as well. So it'll be very similar to Compress in that regard, is that we will tell you, where it's not meeting code along the way.
Okay, and I think we have time for one more question. So the last one is, if my weld forms and other data are stored in the cloud, will I be able to download it to my local machine?
Yes, I know that's always a question that comes up. So since ShopFloor is a native cloud application, you can choose to store everything up in the cloud, but you can also bring it down. When I was telling you guys about that export documents package, what we do is we collect up all the WPSs in the PDF form. So you can produce PDFs from here, and you can pull them down and save them as backups on your local drive if you like as well. Or again, you can keep them all up in the cloud. It's up to you. But you guys are able to retain all of your forms from ShopFloor if you choose to.
All right. Well, that's all for today's Q&A segment. Matt, did you have any final remarks?
Just wanted to thank everybody for attending the webinar. And if I didn't get to your question today, like I said, I'll be going through them. Once the webinar's done, I'll be posting them in a few days. And I'd like to thank everybody for attending. And as always, we appreciate your business. Brian?
Thanks, Matt. I would also like to thank everyone for attending this webinar. Please join us again on March 9th for the What's New in the Codeware Interface webinar. Registration is open at the link in the chat window, and that's at www.codeware.com/webinars. As Matt mentioned, we'll post the Q&A from today's webinar within the next few days. But if you have any further questions or would like to speak with one of our sales representatives, please email sales@codeware.com or call us at 941-927-2670. We'll see you next time.